Hello and good morning. I hope you can hear me. It's so nice to see so many familiar faces. We are for the first time in this auditorium after they renovated it. So one has to get used of it, but I hope everyone is comfortable and we're ready to start. So welcome to what we call CIVIT 10th Anniversary Workshop. The Center for Immersive Visual Technologies was opened in October 2015, and now it's time to report what we have done for 10 years and to see if we can continue with the same pace or even better. This is the agenda for the day, the program. The morning session is focused on automotive imaging, something emerging related with the quest for autonomous cars, autonomous vehicles, and so on. So we have three excellent speakers from industry talking on different aspects of automotive imaging and data. There is lunch. In the afternoon, we have three equally excellent presentations, this time from university presenters, mostly on immersive imaging, like experiences related with extended reality or some other applications which require kind of immersive experience. And then the end of the day, from 3 to 5 p.m., we are going to host you at the lab premises in Sakkutalo, where there will be food and drinks, but hopefully you'll come also for the demos and networking, so in more informal setting. There are these leaflets outside, and they will be also available at the lab, so you can see the description of the demos, where they are, so you can pick one from here, or just come to CIVIT in Sakkutalo SA201, which is in the lobby of Sakkutalo building. And without further delay, I would like to give the floor to Professor Jarmo Takala, the Vice President of Tampere University, responsible for stakeholder relations and partnership, to say some welcoming words.
Thank you, Atanas. Distinguished guests, esteemed colleagues, students and friends. It is a great pleasure to welcome you to all to the anniversary celebration of Center for Immersive Visual Technologies here at Tampere University. A university with ambition to be internationally esteemed, research, impactful in education, strong partner, and active societal influencer. These goals guide our daily efforts and are embodied in everything we build together. At Tampere University, we are creating world-class research environments and advanced infrastructures for benefit of our community and beyond. Facilities like the System on Chip Hub, the Imaging Research Platform, and of course CIVIT exemplify our commitment for excellence. By forging partnerships with industry and the public and third sectors, and by being an active stakeholder in local ecosystems, such as Tampere Imaging Ecosystem, Chips from Tampere, Automotive and Vehicle Technology Cluster, and Tampere AI, we ensure that our research and innovation truly matters, locally and locally. Imaging research stands as one of the Tampere University's strategic profiling areas. The Tampere region is a significant hub of imaging expertise, and CIVIT is at the heart of the thriving ecosystem. CIVIT is not only a leading research infrastructure supporting imaging research and innovation, but also a symbol for enduring relevance and adaptivity. Originating from 3D imaging and visualization, camera rigs, imaging sensors, and pioneering display prototypes, CIVIT has evolved alongside changing technologies, moving from the era of the 3D TV to the frontiers of virtual and extended reality, and expanding into image quality assessments and profiling new imaging devices. Today, CIVIT stands as an innovative cluster organization for companies within Tampere imaging ecosystem, providing state-of-the-art test services that empower both academic research groups and innovative companies. By blending modern equipment and exceptional expertise, CIVIT helps drive advances in imaging and supports the education of future imaging engineers, including through the new international Erasmus Mundus joint master program in imaging. On this special occasion, we celebrate CIVIT's role as a versatile and resilient infrastructure facility, its dedication to continuous development, and its commitment to serving the evolving needs of research, industry, and education. I would like to acknowledge Professor Gotchev, who is the founding father of CIVIT, and he has successfully led the center for 10 years. Great thanks for you, Atanas. And thank you joining today to celebrate CIVIT. Thank you.
Thank you, Jarmo. Thank you for the warm words and motivating words. So we are looking forward to continue with the same pace. And I'm trying to move to my presentation, which is here. Yes, thank you. This is a rather long video, maybe we continue. It all started actually more than 10 years ago, in 2013, when the Vice Rector of Research at Tampere University of Technology, Ulla Ruotsalainen, met me in the corridor and said, why you don't apply for infrastructure funding? And this request was iterated by the head of laboratory at this time, Ari Visser, who again met me in the corridor and say, why you are not applying for infrastructure funding? And there are a few more people here who are saying the same. It's actually dangerous, risky to go along the corridors because you don't know who are going to meet and who is going to motivate you. But yeah, it turned to be a productive request because in 2014 we got this first funding from the Academy of Finland, nowadays Research Council of Finland, of €1 million, which was topped up by another 1 million from Tampere University of Technology, nowadays Tampere University, because this was the requirement of the funding agency. So 50% from them, 50 from the university. So we had a good start with the premise to establish these areas of expertise. And actually it was this immersive moniker inside as the quest of visual technologies to ensure highly realistic and natural visual experience. And this is not only about the hype, but also about the importance, about important applications, from safety critical applications to teleoperation, to XR, to healthcare. And about this photo, it's professionally done, like by Mikko Karsisto from Kehu Interactive, and we license it. We have the full rights to use it, and it has been on our website for these 10 years. And what we like was the uncertainty, like whether the performer is blind or does she see true, or using some supernatural tools to see around. And it was also the color, which was matching the color of the logo designed by Troll SFX, like the company known for their visual effects in cinemas. But as an infrastructure unit, like, we have to offer services, and this nice division of services for researchers, students, and companies was suggested by a consultancy company, Fondon, which we worked with at that time, and it was actually Jan Kolkinen, you know him now, working in the innovation services of the university, who was helping actually to profile our services and to compare them with similar services around the world. So this is what we have been offering for researchers and for students and for innovative companies. This figure at that time was nicely summarizing our premise, like our promise to like who gets what from the pie. Maybe something about the facilities. You're going to visit the renovated facilities of CIVIT today. It is still in SA 201, and it is another story. Like Jari Hietanen once suggested that because we had no facilities. We are in Tietotalo, and then we had to empty it because our wing was to be given back to SUK to be rented by companies, and we are looking where we can move. And there were no suitable facilities, and one day, maybe half joking, he suggested, why you don't transfer this auditorium. It was an auditorium for lecturing. And actually I met Jarmo and asked him whether it is even possible to transform it, and he suggested that we check the load of lecturing. And it turned out that it was not very high, about 20%. It was easy to motivate that we need to transfer, to transform it, to repurpose an auditorium into lab facilities by making 2 floors. We made 2 floors, and then it turned out that the upper floor was vibrating, which is dangerous for cameras. So you cannot actually use many cameras because you cannot calibrate them anytime it vibrates, and we couldn't get any nice 3D footage. So we had to rethink and then cut half of the floor, go to the basement, and this is what you will see today, like the final design of the facility. Of course, we managed to gather a versatile set of cameras. Any possible camera technology, we try to have it, from normal RGB to high frame rate to near infrared to light field camera, 360, thermal, range, hyperspectral, volumetric capture rigs, different custom camera rigs, and so on. This is a demo how our motion capture studio works. So the important part is on the floor, actually, where are the cameras and the infrared lighting sensors, and optical markers put on the performer allows to track the motion and to convert it even in real time to some animated characters. This is a more recent technology, so there are no optical markers anymore, so the motion is tracked by inertial sensors, which makes the whole setting mobile. So this is actually performing in the city center campus. Last year, ITC research event with the same aim to transform the motion into some mixed reality environments. And this is also more recent. I will leave Devanjini to explain the motion, the vocab studio.
Photorealistic human models which can be used for various applications in AR, VR, and virtual production. We invite production studios, creative artists, and researchers in the immersive field to try out our system. We provide services to record and render 3D human models for your requirements.
In what we call XR Studio are the devices, the equipment aimed at extended reality experience. So this is the infamous omnidirectional treadmill, where the user can not only experience visual XR, but can also walk around. So the device replicates motion like in gyms, but in any direction. So the motion cues are synchronized with visual cues, and maybe the person feel more immersed in the environment. We'll have different audio-visual capture platforms for kind of robot type or robotic arm or drones or 360 mics. And we like to show this monster display from Holographica as an example of immersive display. And this is also our own prototype of heads-up display. We demonstrated, I think, 8 years ago, or maybe even earlier. Now, we are going to demonstrate it also today because of its historical value. There is a Finnish company, Distance, now promoting the same technology, and probably we should have patented this 10 years ago. But we learned, we do it better now. Like, for example, in the new Plenoptics lab, we have this, it bridges optical technologies with computational imaging, and also allow measuring the user reaction, like accommodative eye responses and other psychophysical tests specifically for near eye displays. So what you see here is a deconstructed near eye display. So we want to see the human eyes. So the engines are, light engines are from the sides, and then they are combined and presented to the human eyes, and then we can measure also the gaze or the accommodative response and some other objective important metrics. Data sets and software has been an important part of our activities. In fact, for these open data sets and software, we were awarded last year or this year, like the Open Science and Open Data promoter of the university. And this is an example of a vehicle driving in the winter forest around Tampere. And based on stereo vision, we can show what is safe to drive, what is not safe to drive. It was Ihtisham and Oli and Ahmed who collected this interesting data set. In terms of investments, on top of these 2 million at the beginning, along these 10 years, we managed to secure investment of about 3.4 million, and you can see how how they were changing. Also, our focus has been changing and expanding toward interesting devices, interesting equipment. But who uses it? It's a snapshot of projects which benefited from our technology along the years, and there may be more. So this is, I took it from an earlier report. Some of the projects are also illustrated here. We have been very active in Marie Curie doctoral networks. So in fact, we have coordinated 4 such networks. This is the most recent one, Plenoptic Imaging or Plenoptima. The previous one was IMMERSAFE, or Immersive Visual Technologies for Safety Critical Applications. And there were more. This is an example of Academy of Finland research project. The same setting for studying perceivable light fields, so how actually human eye perceives light fields and how then we should model and visualize them. CIVIT has been actively working with companies from the mobile machine or intelligent machine sector, like how to operate them. And this is one example of technology for remote operation of such machine. We were kind of forward-looking because back in 2020, we already knew which machines will need such technology most. Yeah, and this is equipped with the custom vision ring, but the operator is not inside the machine. The operator is away in Sarkotal, in our premises. So the central display is stereo, and the periphery displays are mono, just for providing situational awareness and wide field of view. But the machine is pretty nicely moving, and also assessing the environment. So this tech has evolved from 2020. Now there is a company called OperView, run by Olli Suominen, commercializing this technology. And actually you are going to see the demo today, how they operate an electrical Volvo in the other building. We have contributed to the future fusion to save the planet from energy shortage because of the incoming data centers elsewhere. So fusion for energy is this plasma, or ITER is the plasma reactor where no human can enter because of high radiation. And then all operations must be based on teleoperation by manipulators and based on vision. So in this demo, you can see like a manipulator which must kind of insert a rod or something in an opening. And this is actually our robotic arm demonstrating the tech. And the main thing is the retroreflective markers, which are engraved. And then they help to find the pose of the position of the device and to position it against the target, so that the operation is done accurately. This was the CIVIT team back then, like set after the first round of funding, after this first project that we got from the Academy. We like to call it CIVIT 2.0 because we realized that we must organize it and have it structured and have like staff scientists, a coordinator, and lab engineer, and all these things to make it sustainable. And moving forward, CIVIT was part of the first edition of the MAGICS, the National Infrastructure for Human Virtualization and Remote Presence, where we got money to install the vocab studio. Around this time, machine understanding for mother-infant interaction was another project. Sari Peltonen was coordinating it. So the idea was that psychologists tell us how mothers interact with infants, and we make it with visual tech to quantify it somehow. Collaboratech was yet another project funded by the European Union Regional Development Fund, where we actually built the model for collaborating with local companies in the sectors of work machines and creative digital industries. And this is our current team. Maybe we should call it CIVIT 3.0 for consistency. There was beyond in the title of this presentation. So beyond is that we recently established CIVIT as what we called innovative cluster organization for imaging companies. So this innovative cluster organization came from Business Finland. They wanted to fund such organizations, and we applied for the public funding for this recovery fund after the pandemic. And it is actually nice, better to see this figure. You can see how we evolved from university lab to something like being more like a cluster organization for companies, where probably half of the operations now of CIVIT are aimed at innovative companies from different sectors. And more specifically with this Business Finland funding, we were able to equip maybe the most modern spectral response measurement system in Finland, also known as monochromator. It provides a wide wavelength, very fine step for measuring wavelength response, high accuracy, and wide field of view. So this allows to profile, to measure imaging sensors of a different type. And the other part of this equipment includes image quality assessment. It was done in collaboration with DxOMark, so we got their laboratory, and we are able to issue either their branded report or our own report on quality of imaging sensors. Both the monochromator and the image quality assessment lab will be demonstrated to them. So for experts from companies, we are open to discuss any possible services for you. And because there are many people who helped CIVIT along the years, the only way is to show it in this type of closing credits. Yeah, thank you for your attention. Yeah, there were supposed to be 2 more slides, but I will show them in the afternoon. Or can I show them now? Yeah, they are here, yes. So we are organizing maybe the biggest conference worldwide in image processing. This is the flagship conference of the IEEE Signal Processing Society. It is going to be next September in Tampere, Finland. And me, Alessandro, Natalia, Robert, so Sari, there are many people involved locally in the organization. And we hope to see many companies also presenting there and exhibiting there. So our call is for companies to come and set their booths and show that Tampere is one of the leading industry clusters in imaging. And beside that advanced technical program of the conference, we are going to have also fun. So you know why to attend IEEE ICIP in Tampere. You're welcome. And this is now the end of my presentation. Thank you. I think that we are behind the schedule, so I won't take any questions. But I'm happy to meet every one of you today. So we have a whole day in front of us. So thank you again for your attention.